Hello, this is Yasmin. Welcome to ThatITShow. Before we roll the intro, let's introduce today's episode. In the couple of episodes in the last few weeks, I have been covering topics related to building a home lab. Today I'm going to try to expand on this by working on storage. I already mentioned that how the Ceph storage works on Proxmox, but I wanted to expand on different storage solutions that exist on the market today that are both open source, free, and able to support smaller home labs. So let's do the intro and let's talk about the storage. Now, first let's get one thing out of the out in the open, to say it. The idea of storage is a little bit of a mixed problem when it comes to home labs. Usually, when you have a small home lab, so basically a single machine or a small machine that is not even a whole machine, like something like a Nook or something, usually you tend to do what I did here. So I have a simple Proxmox environment. It doesn't say that it has to be Proxmox. It just happens that I'm using it. And you configure everything on it. So there is no redundancy, basically. There are a couple of disks, but those disks are simply there because I had those laying around. I have a machine that is pretty okay when it comes to CPU power, but it is a single machine. If something breaks, this is going to be the thing that is going to break entirely. So if you have space and funds and the reason why to have multiple nodes for your home lab, this solution is going to look different, and you are going to have different nodes that are going to be running. Each node is going to have its own storage and everything else on it. Now, having a single source of failure, so for example this Proxmox here, means that if my machine goes down, the storage is going down too, so there is no way for me to resume the work in the virtual machine. If you have multiple Proxmox or any other kind of node, what I need to do is I need to have some sort of storage solution that is going to enable me to run the solution on the run the machine while being able to switch the node that it is running on. So I need to introduce the concept of a compute node and storage node. Now with Proxmox, usually what you do is either you configure Ceph on each of the nodes, so you distribute the storage across all the nodes that you have in your cluster, or what you do is you have a separate storage node that may be Proxmox, maybe something else. This also requires one thing that is usually not noted, and this is that if you have multiple nodes and if you want to create a Ceph cluster that works correctly, what you need to do is you need to create a cluster that is more or less symmetrical. So all the nodes should be configured in the same way when it comes to disk space and disk sizes. Now, this is something that is much more complicated because, for example, if you have 3 nodes, this means that for each disk in each of the nodes, you need to have a disk in all the other nodes. So 2 disks in one means 6 disks in total to be able to actually fulfill the idea of symmetrical node configuration. This is not something most of the people want to do. They want to experiment. So what they usually do, they go with the network attached storage or a NAS, and they use this NAS to store everything. You have probably heard about things like Synology or QNAP or whatever, and those are the simplest solution when it comes to local storage. Those are the appliances. Those appliances usually are basically a box that you can put your disks in, usually either 2, 3, or 5 or 6, depending on the configuration. They contain everything that is needed to run the shares and the administration of the disks. So they are the simplest solution when it comes to actually creating your own storage. They are what is usually used in small offices when you don't want to experiment too much, and when you, to be honest, need just a simple storage solution that is able to back up your machines, and that's it. Now, if you are more into home labbing and doing different things and experimenting, you are much more inclined to go with your own configuration, and you're probably going to either use a Raspberry Pi or another old desktop to just put all the disks in it and then configure it as a storage solution. We are going to be covering a couple of those today, and probably a couple of those in the next episode. And I downloaded a couple of them while I was researching this episode. I decided to go with Rockstor, TrueNAS, and Open Media Vault. I'm going to go with the TrueNAS and Rockstor right now, and then probably Open Media Vault is going to be a topic of another episode, simply because of the size and the time. Now, as I said, NAS should be distinguished from something called a SAN. When you are dealing with network attached storage, so NAS, and storage area network, SAN, those are two different things. What is usually meant by those two things is that a NAS is a simple single storage device that is intended to be cheap, and it is intended to be easy to set up, but lacks the features for mission critical loads and so on. A SAN is exactly the opposite. It is usually a device that is intended to be enterprise level. It has multiple servers, it has multiple controllers, it usually has multiple heads. By heads I mean network configurations. So the things that are connecting to it can connect through different pathways, and this usually means that you are also able to have some sort of redundancy. You can have some sort of redundancy when it comes to talking to devices, both disks and controllers and so on. But this also unfortunately means that you have a much more expensive device, and the speed and the convenient factor of being redundant comes usually at a huge price. So to put it simply, NAS is for small offices, home labs, and the SAN is something that you use if you have a larger office or an enterprise or some mission critical load that you need to take care of. The price difference can be huge, orders of magnitude big, even a couple of orders of magnitude big. So you are not likely to confuse those two when it comes to the market. And NAS is going to be significantly more, significantly cheaper than the SAN. Now, the second thing, you won't run a NAS on this virtual machine. This simply doesn't make sense. If you have a single machine like I have here, running a NAS here and then creating a RAID redundant or any other sort of redundant storage on the machine that is going to create all those disks on the same disk, so on the same physical space, doesn't make any sense. If you want to make something that is going to be redundant, you at least need to have it in hardware, so your disks at least should be separate devices that if one breaks, the other ones don't, so that you have some sort of redundancy. So the speed, the idea of the NAS and everything else simply begs for being run on physical hardware. So this, what I'm trying to show today, is just a simple explanation how these things work and look like. But I'm not going into any performance details, because performance in this particular case has absolutely no relation to what real world performance would be. I'm right now running, or I'm going to be running a storage solution inside the virtual machine inside on virtual disks that are going to be by themselves in a Ceph that is going to be on a single node. So more or less everything here is broken and misconfigured, but for the purposes of showing how the thing looks like, this is going to be fine. Okay, let's start with TrueNAS, because TrueNAS is probably one of the most known ones, and the TrueNAS is the successor of the FreeNAS project, and this is one of the well-known projects out there that featured local storage. It was intended to be more or less just a simple extension of a Linux, and while I'm trying to install it, I'm going to try to explain what the difference actually is. So now let's create a VM first. Let's call it 2. Let's say that this is going to be, I'm going to install from my disk that is going to be called TrueNAS Scale. I'm going to be running a normal BIOS. Okay, I'm going to be using 3 additional disks in order to have some sort of redundancy. So 1 disk is going to be for the system, and 3 are going to become a redundant pool. I don't care about the size because I'm not going to store anything on it, so this is just for show purposes only. Now I'm going to give it 8 cores because I want this thing to be as quick as possible. I'm going to also give it 384 megabytes of RAM. I'm going to connect it to my local network, so this is going to be my initial setup here, and I'm going to start it after creation. So more or less this should be a server that is going to start itself, and now I already have the installation. Now while this is starting the install, let me talk a little bit about the idea of how the devices or how the NASes usually work. Just before I do this, just one more additional thing about install. Install here, it is asking me to provide it with a drive that is going to be the one that I'm going to install it on. I'm going to go with the first one. Basically, if it says here that if I select multiple drives, I can provide redundancy. This means the redundancy for the system itself. It is not the redundancy for the data in the pools. So if I use multiple drives here, I'm going to have those configured as redundant drives, but they're going to disappear from the pools. So they're not going to be able to be used in the storage pools. So have that in mind. I'm experimenting here. Single drive is completely okay. Erasing the partitions, okay. I'm going to configure my system through the web UI. Am I going to allow FI boot? No, because I have my legacy BIOS boot set up, and this should be it. My system should be able to boot then. Now, let's talk about, while this installs, about what the main difference between the Linux and the NAS is. Most of the NASes, if not all of them, are more than likely just a well-dressed Linux configuration. This is, for example, a Debian. And the reason why this even exists is because people are completely capable of configuring the shares, the iSCSI, the NFS, the Samba, the ZFS, BTRFS, whatever pools, the redundancy in the networking, the Dockers, and everything else that the modern NAS supports by themselves. So you can do everything by hand in a terminal. What people don't want to do is exactly that. Usually when you want to do storage, and if you want to create your own storage for your projects, specifically in the home lab, where you don't care too much about just configuring another set of parameters for something, you usually want your storage to be as easy to set up as possible. So what people usually do is they use some sort of an NAS, and NAS is more or less just a web interface to an underlying Linux, and depending on the interface itself, you have some more or less functionality available to you. The things that we are going to see here are specifically tailored so that you, as a small, let's say a small office user or a home office user or a home lab user, can configure your disks as quickly as possible. You are probably going to miss some of the advanced features, but at the same time you're getting something that is easy to set up, and most importantly you're getting something that is getting updated all the time. So every one of the NASs that are on the market today offer you updates. It could be that they are paid updates, it could be they are free updates. Some of them involve both. Some of them are have community editions and have paid editions. But anyways, what you're getting a device that can be considered an appliance. So you don't need to log in using SSH and do manual updates. Everything just works if everything is correct. Also, most of the modern storages that are attached to the network offer more than just being a storage. They often support plugins, they support Dockers, they support appliances, but we'll talk about this when you come to those. Now, this has been done. Let me reboot. Let me say reboot the system, and let me see if it's going to just go over its own installation. Yes, it is able to run. Let's let it run and let's boot it up and let it finish booting. As I said, this is essentially a simple Linux that is going to have additional scripts that are going to be done. Now what we are waiting here is for everything to be initialized. ZFS and by extension everything else on the NAS that we are having here requires its own boot time to be a little bit longer, because it has things and caches that need to be booted up, so it takes a little while to load. But on the other hand, the storage is something that is usually 24/7 on, so you don't reboot it often. Now let's wait for the plugins to finish loading, and let's wait for the TrueNAS to actually tell me that I'm able to connect. All of the systems that we are going to be using behave in the same way. They have an interface that is terminal based, but nobody uses it. Instead, we are using web, and web is the primary interface to connect to the machine. You can see here that I can configure interfaces, I can configure routes, I can set up administrative defaults, and so on and so on. But the web interface is in this particular IP address, so I'm supposed to go there. I'm not supposed to use the terminal. So this is 114. Let me quickly just open this and say 1114, and there we go. Now, I can either use administrative user that is called TrueNAS admin, or I can create a root user, which is not recommended. The recommendation is to use another user, simply because it's harder to guess. This is the security part of the thing. I'm just going to create a password. It's going to be a password. And I'm going to be signing in. I'm going to be saving this one, although I don't need it, but I'm going to be saving it. And now we are here at the dashboard. As you can see, the idea of a NAS and the idea of what a NAS is something that actually makes a lot of sense when it comes to usability, because what we have here is a readable, simple dashboard that provides all the information that you need when it comes to your configuration. I can see the amount of memory available to my machine. This is the RAM that I gave to the virtual machine, but anyways, I can see how my CPUs are being used. I can see my storage, currently none is configured. And I can see that basically my machine is not doing anything right now. Also, there are backups to cloud or to another TrueNAS that are possible here. And this is something that is going to be extremely handy. Depending on what you're trying to do, you are either going to be using the interface here, and probably you're going to be configuring, you can also change the layout here, but depending what you're trying to do, you're going to be using this interface here. And this is where main differences across the different storage solutions come into effect. Some of them are going to call the same thing but using different names. Usually a storage pool is a storage pool, but using a name of storage pool does not mean that the pool is going to be the same. Some of the storage systems or some of the NAS systems that we're going to be showing you are going to use ZFS. Some of them are going to be using BTRFS. So the pool may mean different things. Also, the pool may behave differently. So the redundancy can be done in different ways. The requirements for the pool can be different. And this depends on the actual number of disks and the actual storage technology that is used behind the scenes. Now, since I don't have a pool, I don't have anything to show you, so I'm just going to be creating a pool quickly. I'm just going to call it first, and I'm going to say, okay, I don't want encryption. Next, I'm going to say I want to be able to do Z1. You can see a simple pop-up here that is going to give you additional information. You see that there is a stripe and mirror, so I can either use each disk to store the data, no data redundancy. I can use 2 disks to store the data, provides the redundancy, but the thing is that I'm losing a lot of capacity because everything needs to be written twice. Then there is single disk redundancy, double disk redundancy, and 3 disk redundancy that I can use. Then I have something called a DRAID that is able to do the distribution of the RAID. So if I have bigger drives, this means that this is going to be much quicker when it comes to big files. But also, the thing that could happen and the thing that is going to happen is that if I have a lot of small files, then this is not a preferred mode of operation. Specifically, why this is even done in this way, some of the people who are using this for storage usually tend to use this for huge files. Then DRAID is quicker than the RAID Z1. For example, DRAID 1 is quicker than the RAID Z1. But if I have smaller files, then I lose part of the performance, but I don't get the overhead of the small drives to influence me as much. Now I'm going to go with RAID Z1 because I have 3 drives. This means no additional redundancy. So it says here data is going to be 3 times 32 gigabytes. So all the 3 drives are going to be here. I'm not using the duplication here. It's going to just give me the configuration here. Now, also, I can manually reconfigure this, but I don't want to do it right now. So I'm just going to go with whatever it says here that is the default. So next, log disk is going to be none. So next, spare is going to be none. Next, cache is going to be none. Next, am I going to use metadata secure disk? No. I can create a separate device that's going to be doing the duplication. So I don't want to mess with this thing because I'm not into configuring ZFS right now. I'll talk about it in one of the next episodes. Then next, and now let's create a pool. Confirm, continue. A couple of seconds later, the pool should be online. Now, I have created the pool. Creating a pool means that I have created a space that is going to be used to provide storage for different types of storage. As you probably know, but I'm going to assume that you don't, there are two types of storage available or that can be used over the network. One is file level storage, the other is block level storage. When it goes to file level storage, this means that you are able to just store the files across the network. So if you're sending a file across the network, this file is going to be sent as a file, then the other side is going to treat it as a file, save it somewhere, and this is the default that you know if you're using Windows. Now, the other way or the other thing that you can do with the storage is to send blocks across the network. This means that your computer is interpreting the data which it needs, and then requires the blocks to be read from the remote storage, basically treating the remote storage the same as it would treat the local disk. So for example, if you want to read something, your computer is going to request start block from the remote storage, read where the file should be, calculate the block that it requires to read the particular file, and then it is going to require this block to be shown. The thing that is going to happen if you have remote storage done like this is that it is much quicker, and this is the preferred way for the SAN to work. But when it comes to NFS, it is not used as often. It can be done here, and I'm going to show you where to do it, but usually block devices are not used in such a way. Also, TrueNAS by default uses ZFS. ZFS is different than the other systems because it requires it basically includes the partitions, disks, and redundancy is done in the same file system, so it is done in the same way, so you don't need to think about doing scrubbing, so doing the controls. You don't need to think about how the devices are handling the redundancy. Everything is being handled directly by the system itself. It is easier to control. It has a huge number of options, and it is complicated to configure correctly if you have a complicated system, but it is also extremely quick when it comes to storage. So this is probably one of the preferred ways to use the storage if you want to have both speed and redundancy done correctly. Now, when I said correctly, there is only one slight inconvenience. It requires a huge amount of memory and a lot of disks in order to run quickly. So it requires a separate disk for the logs, separate disk for the cache. It requires a lot of memory, so it can use as much as half a terabyte of memory easily if you let it. So ZFS is resource hungry, but it provides the performance that is going to be completely using your resources that you have. Now, we have the topology here, so I can see that my RAID is comprising of 3 disks, B, C, and D. I can see that my RAID is online, so no errors. I can, in the dashboard, now I can see that I have a pool now that is here. I can see that my pool is online. I can see the amount of data it is capable of holding. So 61.62 means that I have a redundancy, 1 disk for redundancy and 2 disks for storage space. So this is just set up now in the most rudimentary way possible. Now, what I can then do, I can now deal with the data sets, shares, and so on and so on and so on. So I can then say, okay, I have the entirety of my disks is available. Now I can say, okay, I need to add the share. When I am adding a share, I need to tell the system which share I'm adding. So is it the Samba SMB, Certain Message Block share that is preferred by Windows? Is it going to be an NFS, the sharing system that is preferred, the file sharing system preferred by Linuxes or Unixes? or is it going to be a block storage device that is going to be a target for different systems that support this? Just have in mind that there is a wizard here also that enables you to do whatever you need to do. Now let's quickly do Samba, and let's just say that there is a path is required here, and the thing is that when you are opening the path here, you have a, I would say, a little bit confusing Dropbox, because path is here, but the Dropbox itself is not a Dropbox. There is a separate Dropbox down that makes this thing possible. So I'm just going to call this thing, I'm going to go and call this thing, I don't know, SMB. So let's say that this is going to be it. Let's say as the first SMB not found. Let me just recheck this. Say create a dataset. Let's say this is going to be SMB. Create. Now I have created hopefully an SMB directory. Yes, name is SMB, and I'm going to save it. Okay, this works. Do I want to start it now? Yes. What I have now is Samba share that is inside this directory. So this is going to be the place where my files are going to be served from. Now I can go to the access control lists, and then I can do the access for different users. I can do the permissions. I can do the either grant or deny, so allowed or denied permissions. Those credentials can be configured here, and I can do some sort of data protection, so I can go to the Cloud Sync, configure the NAS to automatically update things to the cloud. I can do the backups to the cloud to another TrueNAS system. There is something called the TrueCloud. It's a separate service that the TrueNAS uses. So I can do those things here. Also, I can reconfigure the networking. Probably what I would want to do when it comes to NAS, I would want to provide it with redundant networks, or possibly, if they're available, high-speed networks. So, for example, 10G. And it would be extremely beneficial, specifically if I'm using SSDs, so I can have my my disks running at the network speed, or vice versa, I can have my network running at the disk speed. Now, the thing that has appeared here is the virtualization. Virtualization is not supported here because I didn't support the virtualization in the virtual machine. So since I'm running my TrueNAS in the virtual machine, and the virtual machine is not configured to be supporting virtualization, I cannot see it here. But if my processor supported the virtualization, I would be able to run virtual machines here. Also, there are apps. I can go to the applicable apps and find different things that can be used. I can refresh the catalog here, and then I'm going to be seeing a lot of different things. What these are basically Dockers or containers. So apps can be run as a thing that you can run on your NAS. And the reason is simple. People realize that once you have the hardware configured for your NAS, nowadays the hardware is much more powerful than it should be for the simple task of serving files. So they enable you to run the machines or Dockers to do things like DNS filtering. You can have direct connections to Postgres the databases, to REST-Sync. You can store your passwords here. You can do NVR, so recording from IPTV cameras. You can do dashboards. You can do Cloudflare, so the tunneling directly to your machine. You can do monitoring by Prometheus. So you can do a lot of things, and there are a lot of apps for different systems that are going to enable you to do much more than just having a disk being shared. Also, there are reports here. The reports are going to be important usually when you have a problem. For example, you can see your usage of the disks, how many writes, how many reads do you have on different disks, so you can spot if there is any if there are any problems. And then there are just regular bureaucracy things that need to be done when it comes to the system. So the updates, the settings, the boot devices, services that are running, and so on and so on and so on. Updates are can be changed. So you can either use the release updates, or you can use the test updates, so the pre-release builds. But this depends on what do you want to do. So you can go on the nightly train, and there is other upgrade options if you click here. I'm not going to, because I don't care about those right now. But just bear in mind that almost all of the different systems that we are going to be showing you have the same idea. You choose, do you want the stable release, or do you want to have the latest features available to you? Okay, this is TrueNAS. I'm just going to leave it as it is, and I'm going to quickly go and install the other one being Rockstor. Let me just quickly spin up another virtual machine. Let's say this one is going to be called a Rock. So Rock, I'm going to say that this one is going to be done by here, Rockstor. I'm going to use the default. I'm going to also put 3 disks additionally on it. I'm going to also give it 8 CPUs. I'm also going to go with 16384. I'm going to go with bridging to my local network, and this should be it. I'm also going to start it at the creation, and then I'm going to wait for it to show up. As you can see, it quickly booted. I don't want to boot from a hard drive because it's not installed yet. I'm just going to be installing it. Now, Rockstor is a little bit different when it comes to the installer. Installer is based on SUSE, and it is a little bit different because it requires a long wait for it to be done. Let me just go to destroy all data on dev. Okay, leap. Let's just get it to boot its image. So it is just loading things up. Now, the thing is that the difference is that it requires a long time for the first start. This is a direct, basically the direct result of the way that the installation itself is done. Installation is extremely quick. You're going to see that it's going to be over in a couple of seconds, basically. More or less under a minute when it comes to from start to finish. But the thing is that then it requires reconfiguration in a pretty much the same way that Windows does it sometimes. So what they are doing is they are just block copying a generic image, and then when they are first running it, they're configuring everything to be configured on this particular piece of hardware. This means that we are going to be waiting for a couple of minutes for the machine to be up, and this is going to become obvious as the machine reboots. Now, what is the idea behind Rockstor? Theoretically, there are no differences. TrueNAS and Rockstor are just different projects. Some people prefer one, others prefer the other. TrueNAS is a direct descendant of something called a FreeNAS, and this was a pretty popular project when it came to storage. Rockstor is something that is much more recent and much different. But the thing is that when it comes to particular particular thing in one or the other, they are mostly the same. But the thing that I need to mention is that the differences are pretty stark when it comes to user interface. So let me configure this thing before that. English keyboard layout is going to be UK. I'm going to accept the agreement. Europe, London, I don't care. Root password is going to be password. It is warning me that the password is bad, but it doesn't care. Okay, now the thing is that it says that your web UI should be available directly after OK finished Rockstor bootstrapping tasks appears below. And then it says first log in here as root user for further instructions. Now, if I log in here, it is going to tell me how to refresh the system. I can use the OpenSUSE zipper application, which will be known to people who are using OpenSUSE. And what I could theoretically do right now is I could type in my IP, and I would see that my IP is 192 and so on 99. So I'm going to go with 192.168.99, and nothing is going to happen. It is going to probably notify me that it is unable to connect. The reason for this is because the system has not been configured yet. Now, what is happening in the background is that different tasks are being performed to prepare the system for the first run. So what actually is happening, if I just go take a look at the processes, I can see that a lot of things are running, but those things are running because the system is now just being prepared. So I'm waiting for the system to come online. The system uses Nginx as a proxy, so even if the system itself is not online, you are going to see that you are able to connect. So I'm going to go with advanced, I'm going to accept the risk and continue, then it is going to tell me a bad gateway. This is normal because Nginx takes a lot less to run than the rest of the system. So basically what I'm now waiting for is the system to come back online, and I'm waiting for the system to become available, or I'm going to try to refresh, but nothing is going to happen. So basically I'm waiting for the system to come online and to notify me about this. As I said, this is going to require a couple of minutes. While we are waiting, let's just do a little philosophical thought experiment. Do I even care how good a particular user interface looks like if it performs well? One could say that TrueNAS has a pretty polished interface right now. It is much prettier than it used to be. The one before this one, I wouldn't call it ugly, but it wasn't as nice as this one. You're going to see that Rockstar has an interface that is much older, and it looks old. If you have ever used Synology, you know that their ones looks polished, but from the perspective of somebody who has used almost, if not all of them, I must say that I don't care. As long as I can configure correctly and reliably whatever the system is underlying the user interface, the only thing that I care about is the ease of use and the ability of me to do my task quickly. I want to be able to do tasks quickly, and I want everything to be as automated as possible. So for example, I want my system to be able to tell me when something is wrong. I want my system to be able to tell me, to notify me if a disk is a problem. I want my system to let me configure the storage pool in as small number of clicks possible. So what I want to do is I want to be able to establish my tasks quickly. I don't want to have to do too many clicks. Also, I don't want to use my terminal, and this is the only thing that I require from the machine like this. Now, let's see. Finish the Rockstor bootstrapping tasks. Let's try to refresh. Let's see if the machine is up. It is going to be slow. Let's start. Yes. Okay, now let's accept the agreement. Let's go with the username. Username cannot be the same as the username for the system, so I'm going to call it a user. No, I'm going to call this one rock, and I'm going to call this one user, and I'm going to say that I'm going to use the same password. Okay, save, whatever. So one thing to note, Rockstor is a community open source development project. It has its own subscriptions, so you can actually give money to the project, and I strongly suggest that you do that if you plan to use this as your daily driver. If you're experimenting like I'm doing right now, it is fine to ignore the project, but have in mind that somebody is actually using their own time to develop this. So don't just say no thanks always. Sometimes you can just switch over to the different update channels. They're going to provide you with much more polished experience because they contain daily fixes. Now, as you can see here, the interface looks quite differently from the TrueNAS. TrueNAS one is here, so let's do no. So this one looks like this. This one looks like this. So this is much older style of interface. I wouldn't call it old, but older style of interface. You can rearrange it. You can actually rearrange it the same way as the interfaces are rearranged here in TrueNAS. You can reconfigure it here also, so you can actually rearrange the interface here. So the beauty is in the eye of the beholder. I don't know. I must say that what I like about this interface is the way that the widgets look. This widget with disk activity is so much easier to read than this one. Or specifically, there is not even a storage one on right now, so I need probably to go and click through the interfaces and see what is the storage load right now. I much prefer this one. It may not look as good as the other one, but this one gives you more information. Now, let's quickly go and configure the same thing that I configured in the TrueNAS. I go to storage. I go to disks to check if my disks are online. I can see the disks that are here. I'm going to go to pools. I'm going to tell it to create a pool. I'm going to also name it. Let's call it first. RAID configuration is going to be RAID 5. So I'm going to say for RAID 5, no compression. Mount options, I don't care about those. I'm going to select all of the disks. It is going to give me the idea of what it is doing. So it is using all the disks. I'm using one for the redundancy, so the same as the TrueNAS. I'm going to submit. And now my pool is online. In order to create a share, I can just create a share here. It requires a name. Let's call it test. I need to say which pool is going to be the source of the share. So the first one. I'm going to use the entirety of the pool, and I'm going to tell it to submit. That's it. I now have a pool called a test. I can go to it. I can see what the size is, what the access controls are. I can do the snapshots, and so on and so on. Now, when it comes to file sharing, I can do a Samba export. I can do an NFS export. So this is a little bit different. In the TrueNAS, what I'm doing is under shares, I'm creating a share that is going to be on the particular path. In the Rockstor, what I'm doing is I'm doing an export of existing share that is configured. Also, I need to turn on the NFS service. Now, one interesting thing, okay, I can do the updates, the appliances, and so on and so on and so on. I don't care about those, email alerts and so on. The interesting thing that is here is the so-called rock-ons. If I turn those on, it's going to ask me where to put the disks. I'm going to submit this. Then it is going to ask me to turn on. Okay, rock-on is now turned on. Let's go here. Let's turn the thing on again. Let's wait for it to spin up. Now I can press update and I can wait a little bit. You can see that the Rockstor is inherently a little bit slower than the TrueNAS. From my perspective, it is a little bit more intuitive when it comes to using it. And I must say that although TrueNAS looks better, Rockstor is a little bit more on the side of usability from my perspective. So this is something that I would probably be using over the other one. Now, as you can see here, we have Calibre, we have Booksonic, we have Gotify, we have headphones, we have JDownload, Kanboard or Kanban board, MariaDB, Minecraft server, and so on and so on. And actually from the name itself, it says it's a custom Docker image. So these are basically Dockers. So what you can do here is you can go and install any of the Dockers that you need. I don't know, one-time password installation. You say this is going to be on the next test, next. What is going to be the port, next. Okay, I need the URL. I don't want to install this now, or I want something easier to install. So let's install let's install something that's going to be easy. This one. Config storage test, database location test, data storage test. Next. Okay, I need to remake the series. So anyway, I'm going to just skip over this because we are way too long on the episode time anyway. You can configure the Dockers and you can just put them up and use them as you would normally use the Dockers on any other system. So rock-ons are mostly add-ons that are just Dockers. You can go through the support. You can go to the Open Collective site and you can then donate to the budget. So they say that this is the estimated annual budget that they have. They have the sustainability amount that it takes for them to actually be sustainable. It says that they are able to raise 9,000 euros by this date. Today is 23rd of January. So they are going to be covering themselves if this trend continues, but they need contributions. For the contribution, you get the code, and then if you get this code, you can use this to enable the different channels that are going to give you new updates. So basically the system and the software updates are going to be able to go and use the different version of the updates, the newer one. Okay, these are the two available systems that I wanted to show you. And these are probably the most simple ones when it comes to configuration. There are also a couple of others that do different things. I'm going to be, in the next episode, I'm going to be trying to unravel the Unraid and how to install it and how to use it. Also, what I want to mention is there is a Xenology NAS, which is trying to be a port of a Synology system, so the interface, to the Intel hardware. what it is trying to do is it is trying to run on a normal regular server and then enable this server to be on normal Intel hardware instead of actually needing to buy Synology. So if you want to run a DSM, so the software that the Synology itself uses, you can run it on the regular server, so you don't need to invest into Synology hardware if you want the experience that Synology provides you. I must say that I'm not a big fan of this. Because I want to see something different. I very much prefer either an Unraid or a Rockstor or a TrueNAS over copying Synology, because Synology is Synology. If you want to have a Synology experience, you just buy the device. Okay, on that bright note, thank you for being with me, and see you in the next episode where I'll be going through the Unraid and trying to put up different Dockers in it and try to do try to introduce you to the thing that Unraid does the best, and this is basically creating a symbiosis between a storage device and an appliance that is able to run different Dockers and also virtual machines. Something that you can see here, but only in its essence. So there is Rocons here. In TrueNAS, you have apps in virtualization, but from my perspective, this is something that Unraid has done first and is doing much better than what is on the market right now. But as you can see, they're trying to compete with each other, although they are open source projects, and you cannot create a big mistake choosing one over the other, except that with some of those you're getting much more many more appliances and many more Dockers available in the default configuration. You don't need to create your own, but more on that in the later episode. Thank you for being with me. This was the IT Show, and see you in next installment.